Hello everyone, today we'll be discussing the two-way ANOVA. To do a two-way ANOVA in SPSS, we first go to Analyze, then to General Linear Model, and then to Univariate. The General Linear Model is a very general method, and this means that there's many options here that you don't have to use for a two-way ANOVA. So in fact we can ignore the lower half of this part, so no random factors, covariates or weights. We just use the dependent variables and fixed factors. So to do a one-way ANOVA with this method, we use one dependent variable. This is the CSUM2 dataset. We'll use postlet here, and as fixed factors we have ViewCat. Now we have a one-way ANOVA. To make it a two-way ANOVA, we add one more fixed factor, sex. As you can see, it is shown as ordinal here, and if you look at the data, it is 1 and 2 instead of 0 and 1. But for the two-way ANOVA and the one-way ANOVA, you don't have to create dummies, and it doesn't really matter what these values are because they are taken as factors, which means they are not considered to be numbers anyway. This is sufficient for a standard two-way ANOVA. So if we click on OK, we will have our first output. However, there is much more that can be done with this particular method. So if we go back, and our first option is model, and by default, as you can see here, we have a full factorial model, which means an intercept, all main effects, and all interaction effects. We can change this with build terms, and this allows us to choose what we want to do. So here we have type interaction. That doesn't actually matter for what you do. If you just click and thing, here we have a main effect, and here we have another main effect. Why does it say interaction? Because if you select them both at the same time, so that you do that with shift click, you will get an interaction effect. If you change this to main effect and you select them both with shift click and you move it here, you have two main effects instead. So with this method you can create interaction effects fairly easily, as well as main effects. There's these strings below are not going to be used here, but just if you ever end up with three factors, I will show you this. We'll add side for a bit, we'll remove it soon again, and if you now you want three main effects, so this is if you now create an interaction effect, it's going to create a three-way interaction. But if you want three two-way interactions, you can do all two-way, and it will create them all at once instead of you having to select two each time. So you're not going to be using this for now. You have sufficient with just interaction and maybe main effect. So going back to full factorial, here you can include the intercept. You usually include it, so just leave this here unless stated otherwise. Don't touch this either, it's difficult. So we're moving side again. Now we have contrast and bootstrap are just like last time, not something we will cover in this course. So instead we go to plots. There are several possible plots to be made here, and they show you the estimated marginal means per value of a group. So for this we can create two main models, ViewCat and sex. And if you want to create an interaction plot, you can add one here and the other here. And now we have an interaction plot. For one thing, I'll just want to show you. There's on the bottom here, there's option y-axis starts at 0, and I want to show you why this is important to select, because if you don't select, you get this issue. Now it seems like there's a huge effect of gender, while if you look at the estimated marginal means, it's actually a difference of about 1 point. So on a scale of 26, that's not much. So why is this option by default not clicked? Because it pulls apart the graph and makes it easier to see things like interaction effects. But overall, I would recommend using this unless you have a good reason not to. Don't know if Beth has the same opinion on this, but we'll see. So we have 3 possible graphs. For the interaction graph, I generally would recommend putting the factors with the most options. So FewCat has 4, sex has 2. So FewCat will go on the horizontal axis and sex on the vertical one, or in separate lines. Why do I do this? That's because this will reduce the number of lines in the graph, which will make it easier to see any effects that there are. So we now click OK. We have 3 graphs, one for sex, which is now suddenly nearly flat because we start at 0. FewCat, which does increase, and here is the interaction effect. So per sex, the effect of FewCat. So that's so much for the plots. I'll remove these. I will be removing a lot of things today because there are a lot of options. Post hoc tests are very similar to what I showed you in the previous one-way ANOVA video. The only difference is that you can select which factor you will do a post hoc test for. So post hoc tests are always t-test-like tests, so you have 2 options per thing. So it can't you do any interaction effects or anything like that. So you can just select FewCat and you get the post hoc for FewCat, and if you select sex as well, or instead of FewCat, you will get post hoc test for sex. So that's it for FewCat and sex. Sex will actually probably not need a post hoc test because it only has, it doesn't even appear because it only has 2 levels. So this one you can read from the ANOVA table. So if for sex the post or is any binary option variables, the post hoc test does not appear, that is the reason. Going on, we have EM means, the estimated marginal means, and this is basically the mean you would expect for a group, ignoring the other effects. So this will be the means for FewCat variables and the means for the sex variable. So this can be helpful because it shows you basically what means to expect and what the differences are between groups. So that's the estimated marginal means, and it has this weird thing where it multiplies with me, so please do take that into account if you suddenly get a lot of graphs. That's probably the reason. Then we have again the save option, which is also almost identical to what we saw in univariate. So we here have the predicted values, and residuals and the distances. Options is this time quite useful because it can give you things like descriptive statistics, estimates of effect size, homogeneity tests. This is again Levine's test, and even things like observed power and parameter estimates that we won't be using, I think. So, and one thing before everyone doesn't ask me next time, this would be the effect size, and it's probably covered in the slides as well. So please do watch the videos, but the effect size is not a separate table. It's just part of the ANOVA table. So that was it for my overview of the two-way ANOVA. I hope this was helpful and good luck with your exercise.